first let's look at silver plus magnesium nitrate. So the first thing we have to do when we have a compound is look at our activity series. So the activity series lets us know which cation will take the anion. So the higher it is on the list, that means if it's higher on the list, that means it will take the anion. So lithium's at the top of our list, it will take the anion from anything below it. Gold, Au, is on the bottom of our list, that means everything else on this list will take the anion from it. So a reaction will only occur if the anion is changing from one cation to another. So find silver, Ag, put your finger on it. Find Mg, magnesium. Which one's higher on the list?
Mg.
So Mg will take the anion. But here Mg already has the anion. So is there going to be a reaction? No. So in this case you would just write Nr, no reaction. Because magnesium already has the anion, so it's going to keep it. Now let's look at the flip side of that. What if we added magnesium to silver nitrate? Which one's higher on the list, magnesium or silver nitrate? Magnesium. So magnesium is going to take the anion. So in this case, is there going to be a reaction? Good, because magnesium is going to take this anion, NO3 negative. So we'll end up with, so we start with solid magnesium here and an aqueous solution here. We end up with solid silver, because we know it's solid at room temperature when it's by itself, plus magnesium nitrate. Now magnesium is a +2, nitrate's a -1, so we're going to need 2 nitrate ions to balance it. Okay, so right now we have an unbalanced molecular equation or formula equation. To balance it, I need to see I've got 2 nitrates here and only 1 here. So I need a 2 here. Now I have 2 silvers on the left and only 1 on the right. I need a 2 here. Now we're balanced, okay? Now we'd write our complete ionic equation. So magnesium is a solid, it's neutral, it stays by itself. Silver nitrate, the charge on silver is, remember zinc's a +2, silver's a +1. And then we have the 2, means we had 2 of both of these, but they're floating around in solution separately. So we have 2 silver, but we also have 2 nitrate. These are both aqueous. That yields on the right 2 silver, but now magnesium's got a charge because it's part of the compound. So we have 1 magnesium, which is a +2, and we have 2 nitrates, which are -1. Okay? Now, remember what a spectator ion is. It's an ion that's not part of the reaction. So it's going to have the same charge and the same state of matter on both sides. So which one of these is a spectator ion? Good, so that's not part of our net ionic. So our net ionic will be what's left. Solid magnesium is added plus silver, 2+, yields silver plus magnesium. Now, take a look at their charges. Which particle is oxidized? Which particle is reduced? Remember, reduced means the charge is going to be reduced. So which one of these two charges goes down in value? Silver or Ag? Good. It goes from a +1 to a 0. So our reduction half reaction is going to be this particle, silver, is reduced. and that means magnesium is oxidized. Its value increases. So our oxidation half reaction is going to be solid magnesium, and we end up with a charge of +2 over here. So we have magnesium magnesium +2. What did it have to get rid of to become a +2? 2 electrons. Now our reduction half reaction, we start with 2 silvers, right? In order to become 2 neutral silver atoms, 2 electrons. Okay.
So is the reduction always like, is it always in that formula?
It's always going to have, the reduction is going to have the electrons on the left. Because this is showing us like the steps. First, magnesium gets rid of 2 electrons, right? Silver accepts those 2 electrons. The second. So let's take a look at what this is saying. If we go to we go down to our virtual lab we did, and what we just did was a reaction of magnesium and silver nitrate. So we have magnesium and we placed it in silver nitrate. Now this is just saying that they're not showing us water and NO3 minus because it's not part of the reaction. It's not doing anything. So they're just showing us the rest. So there's silver, magnesium, 1 magnesium ion gets rid of those 2 electrons, each silver gets it, and the magnesium floats away into solution because it's now part of magnesium nitrate. The silver is a solid now, and that's what's building up on the side of the little magnesium bar. So that gives us that transfer. Here we have our net ionic on the bottom that shows us the different charges. Now there's 2 silvers coming across. Magnesium becomes a magnesium with a +2 and 2 electrons. To give us that equation. Remember, if nothing's written, it's implied that it's 0. And then silver, each silver gains 1 electron to become a neutral. And then the magnesium is floating away in solution because it's aqueous, and the silver is staying here because it's a solid. Good?